Today's lesson is about powers and exponents. You're going to learn how to write a power, how to solve a power, and to show that a power is just an easier way to write down repeated multiplication. Let's get started. So here's some key terms. A power is made up of two parts, a base and an exponent. The base is the larger number, and the exponent is a smaller number. Here is an example of a power. You can read this as 7 to the 4th power, or as 7 to the power of 4. What you see is the larger number, the base, is on the left, and the exponent, the smaller number, is written in what we call superscript on the right. Every power is written this way, unless it's in standard form, which would mean that it is either solved, or if it's written in expanded form, it would be the actual multiplication problem used to solve this. Right now, this power is written in exponential form. So when a power is written with a base and an exponent, you can say it's written in exponential form. Now let's get into figuring out how to write down these problems as repeated multiplication. 4 to the 3rd power is just telling you that you need to write down the base the number of times the exponent tells you. So here, I'm going to write down 4 3 different times, and I'm going to multiply all of those 4s together. Keep in mind, this is not addition, so the answer to this problem is not 12. You have to multiply 4 times 4 times 4. Okay? 5 to the 6th power is exactly the same as this one. We're going to write down a 5 6 different times and multiply all of those 5s together. So what you'll probably think about now is that these numbers are going to get pretty large pretty quickly. So we're going to solve these in a moment. Let's start with 4 to the 3rd power. One other thing I want to mention about this power before we start is that 4 to the 3rd power actually has an additional way that you can say it. When a power has a 3 as its exponent, you can also say cubed instead of 4 to the 3rd power. So I could say 4 cubed for this problem. Let's solve 4 cubed. Write down our math problem as 4 times 4 times 4, and let's just start multiplying left to right. The first multiplication problem we'll do is 4 times 4, and the answer to that problem is 16. So if we solve that, we get 16, and then we have one 4 left over that we haven't used yet. So when we multiply 16 times 4, work it out, you'll figure out the answer is 64. So 4 to the 3rd power, or 4 cubed, is equal to 64. Now let's try 5 to the 6th power. This one's going to take us a little bit longer because there are more multiplication problems to solve. But we write our problem out first, just like we did on the previous slides. So 5 times 5 times 5 times 5 times 5 times 5, that is 5 to the 6th power. And we're going to start here with 5 times 5 on the left. So if I multiply 5 times 5, I get 25, and I write down all those other 5s that I haven't used yet. I continue to multiply. The next problem is 25 times 5, and that answer is 125. I like to think of multiplying with 25 like quarters. If I have 5 quarters, I have $1.25, which here would be 125. And I write down the other 3 5s that I have not multiplied with yet. Continue multiplying, 125 times 5. If you work that out, you'll figure out that equals 625. I still have 2 5s that I have not multiplied with yet. So I'm going to multiply again. 625 times 5 is equal to 3,125. I have 1 5 left. And if I multiply that last multiplication problem, my final answer is 15,625. So what you'll notice is that a common mistake here is that people will say the answer to this problem is 30. If you say the answer to 5 to the 6th power is 30 because you multiply 5 times 6, you can see you're way off of the answer. The answer is 15,625. So now let's talk about one kind of special power. Powers with an exponent of 0. There is a rule for this, and I'm going to show you how the rule works and why it works, but what you have to remember is that anytime the exponent in a power is 0, the answer is going to be 1. So 5 to the 0 power is equal to 1. 9 to the 0 power is equal to 1. 24 to the 0 power is equal to 1. And you guessed it, 1 to the 0 power is equal to 1. What I want to know is why. Let's figure out why. We can do this by making a pattern. So what I'm going to do is solve all of these problems. And I'm going to take a look at the answers to those problems and see if they form some sort of pattern. So let's start with 2 to the 4th power. Remember, 2 to the 4th power is 2 times 2 times 2 times 2. So if you work that out, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 2 to the third power is 2 times 2 times 2. So again, remember, it's not 6. It's 2 times 2 is 4, and 4 times 2 is 8. 2 to the second power is just 2 times 2, and that equals 4. Anything to the first power stays the same. So 2 to the first power is 2. So now let's look at the solutions. There's a pattern here with the solutions. And what you'll notice is that 16 divided by 2 is equal to 8. 8 divided by 2 is equal to 4. 4 divided by 2 is equal to 2. So if I continue that pattern and I do 2 divided by 2, 2 divided by 2 is equal to 1. So you continue that pattern down and the answer is 1. That works for every single base. So even if the base is not 2, the pattern that you form will lead you to the answer of 1 when you get to the 0 power. So let me show you one more example of that. Okay? So every base creates a pattern similar to this one. So let's look at with a base of 3. 3 to the fourth power, I solved these all for you, is 81. 3 to the third power is 27. 3 to the second power is 9. 3 to the first power is 3. So the pattern here is that all of the answers in red, you divide by 3 to get to the next one down. So 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 then would actually equal 1. So it leads you to the same answer here for a 0 power. If you noticed, the number you divide by for the answers is always going to be the base. If you divide by the base, that's how you get the pattern. So what you need to remember, you don't need to memorize the reasoning for this. You need to know that anything to the 0 power is equal to 1. Okay. Last thing we're going to go over today is writing a power when you're given the base and a solution. So we have to find the exponent. So the example here is 2 to the x power is equal to 64. Here's what we know. In order to solve a power, you keep multiplying by the base over and over again. So we basically have to figure out how many 2's we need to multiply with to get 64 as the answer. So the most common answer is 32 because you think like 2 times 32 is 64, but that's not how powers work. We just have to keep doing repeated multiplication. So let's try this out and see what happens. 2 times 2 we know is not 64. 2 times 2 is 4. So we have to add on an extra 2. If I do 2 times 2 times 2, 2 times 2 is 4. 4 times 2 is 8. 8 and 64, that's not what I'm looking for. So I have to add another 2 on. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Still not the right answer. Add another 2 on. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Still not the right answer. I got to put another 2 on here. Okay, so if I add one more 2 on, what I'll notice is that if I multiply all of those together, this was 32 times 2 at the end here, so 64. I used 6 2's to get an answer of 64 for my power. So what that means is 2 to the 6th power is equal to 64. We'll do some more examples like this one later on in practice and homework. But again, you just take your base and you keep multiplying by that base over and over and over again until you find the answer you're supposed to look for. The number of 2's that you use or the number of base numbers that you use is what you put for your exponent down here. Okay, hope this video is helpful. As always, use this for homework notes, studying for quizzes and tests, and I'll see you next time.